All right, guys, we're going to go ahead and look at example 1. So for example 1, what we can do is we can take the cubed root of the top number, which is 216, and the way you're going to do that on the calculator is you're going to go ahead and hit second, and then you're going to go ahead, you're going to go ahead and hit the 3, because we want to do a cubed root, and then second, and then caret, and that will let you do cubed root on your calculator. So you're going to take the cubed root of 216 to find what's going to be in the numerator, and then you're going to take the cubed root of 343. So the cubed root of 216 is going to be 6, and then the cubed root of 343 is going to be 7. So you should have gotten 6 over 7 for example 1. So for example 2, we need to write the square root of 152. And on our calculator, we can do that pretty easy by just hitting second and then x squared, and then typing in 152. And when we do that, we're going to get 2 square root of 38. All right, so let's go ahead and try the 2 practice problems. Go ahead and try those 2 on your own. All right, so example 3, we want to write an equivalent expression in the lowest terms. So the way I would solve this is I would break everything up, and I would first take the square root of 56 on your calculator, which you're going to do by hitting second, and then you're going to type x squared, and then type 56. And you get 2 square root 14. Then I would take the square root of x to the 4th, which is the same thing as, remember, this has an index of 2. So that's the same thing as x to the 4th divided by 2. And 4 divided by 2 is just 2. So the square root of x to the 4th is actually x squared. Then I'm going to go ahead and take the square root of y to the 7th. And when I do that, I'm going to get y to the 7 divided by 2. Now, 7 divided by 2 is going to be 3 remainder 1. So I'm going to get y to the 3rd, and that remainder is going to go back under the radical. And then finally, I'm going to go ahead and take the square root of z to the 20th. So I'll have z to the 20 divided by 2. And when I do that, 20 divided by 2 is 10. So the square root of z to the 20th is z to the 10th. And once I've written all that down, now I can put it together. So everything on the outside of the radical is going to go together, and everything on the inside is going to go together. So I have a 2, so that's going to be on the outside. And I have an x squared, that's going to be on the outside. I have a y to the 3rd power, that's going to be on the outside. And I also have a z to the 10th, that's going to be on the outside. Okay, and I'm going to write this a little bit lower so I can fit it all in. So I have 2x squared, y to the 3rd, z to the 10th. And now I need to go ahead and write everything that's on the inside of the parentheses, or sorry, the inside of the radical. So on the inside, I have a 14, and I also have a y. So I would simplify this into 2x squared, y to the 3rd, z to the 10th, and then I have the square root of 14 times y. All right, guys, so example 4, we want to solve the following equation for x. So we need to get x by itself. So the first thing I'm going to do is I'm going to get rid of the parentheses by using the distributive property. So if I distribute 3 times negative 5, I get negative 15. And then 3 times negative x becomes negative 3x. And then I'm going to bring all of this down. So I have the plus x equals negative 10 minus x. Now I like to go ahead and draw a line just to stay organized. And what I'm going to do is I'm going to go ahead and combine like terms. So negative 3x plus 1x would become negative 2x. And I still have the negative 15 and all of that. All right, now I'm going to go ahead. I have variables on both sides, so I'm going to bring the smaller variable to the other side. So negative 2 is less than negative 1. So what I'm going to do is do the opposite of subtraction, which is addition. So I'll add 2x to both sides. And when I do that, the negative 2x and the positive 2x, they cancel out. So now I just have negative 15 equals negative 10, and then negative 1x plus 2x becomes just x. Now I'm going to go ahead and I'm going to keep solving for x, and since there's a negative 10 with the x, so I'm going to add 10 to both sides to get the x by itself. So now I have x is equal to 10 minus 15, which is going to be negative 5. And I can just rewrite this as x is equal to negative 5. All right, go ahead and try the 2 practice problems on your own. All right, example 5. Ashton solved the following equation for x. Let's go ahead and solve for x and figure out how Ashton did it and how we would do it. So the first thing I'm going to do is use the distributive property. So I get 7 times negative 2x, which is negative 14x. And then 7 times 2 just becomes 14. And it looks like Ashton did 7 times 2, and he just got 2. He should have gotten 14. So right off the bat, I can see that Ashton made a mistake on step 1. He did not distribute correctly. But let's go ahead and finish this up and see what we would have gotten. So this is equal to 4x minus 40. I'm going to go ahead and solve by